Hi there. This is a realistic DevOps interview simulation focused on Kubernetes fundamentals and how they fail in real production environments. These questions are designed to test whether you understand not just what Kubernetes is, but how it behaves when things go wrong. Before listening to each answer, pause the video and respond out loud as if you were in a real interview. That's how you build confidence and spot gaps in your understanding. If you find this useful and want more long-form DevOps interview simulations like this, subscribe so you don't miss the next one. Let's start with a few warm-up questions. Tell me about the first time you worked with Kubernetes in a real environment. A strong answer would sound like this. The first time I worked with Kubernetes in production, the biggest challenge was mental rather than technical. I had to stop thinking in terms of individual servers and start thinking in terms of declarative state and controllers. Early on, I spent time understanding how deployments, services, and pods interacted, and I learned quickly that most issues weren't about Kubernetes being broken, but about my assumptions not matching how the system actually worked. Next question. Tell me about a Kubernetes-related incident you've been involved in. A solid response would be, we had an incident where pods kept restarting and traffic was unstable. At first, it looked like a cluster problem, but after digging in, we realized resource requests were misconfigured. The scheduler packed too many pods onto a single node, and under load, they started getting killed. The fix involved adjusting requests and limits and rebalancing workloads, not touching the cluster itself. Another one. How did Kubernetes change the way your team handled failures? A good answer might be, Kubernetes made failures more visible and more frequent, but also less catastrophic. Pods fail and restart all the time, and that's expected. The shift was learning to design systems that tolerate those failures, rather than trying to prevent every restart. It forced the team to think more about resilience and less about individual machines. Next question. Tell me about a mistake you made early on when using Kubernetes. A strong response would be, early on, I relied too much on restarting pods to fix issues. That sometimes masked deeper problems like bad configuration or application bugs. Over time, I learned to treat restarts as a signal, not a solution, and to investigate why Kubernetes was taking the action it did. One more warm-up. How do you explain Kubernetes to someone who's comfortable with VMs but new to containers? A solid answer would be, I explain Kubernetes as a system that manages containers the way a hypervisor manages VMs, but at a higher level. Instead of caring about individual machines, you describe what you want running, and Kubernetes works continuously to keep the system in that state. The key difference is that Kubernetes assumes things will fail and is built to handle that. Let's move into technical and scenario-based questions. At a high level, what problem does Kubernetes actually solve? A strong answer would be, Kubernetes solves the problem of running containerized workloads reliably at scale. It handles scheduling, restarts, scaling, and service discovery, so teams don't have to manage those concerns manually. In production, that means you can focus more on application behavior and less on individual hosts, as long as you understand how Kubernetes enforces desired state. Next scenario. A pod keeps restarting in Kubernetes. What's your thought process for debugging that? A solid response would be, I start by understanding who is restarting the pod and why. I check whether it's crashing due to application errors, failing health checks, or hitting resource limits. I look at events, logs, and restart counts to build a timeline. The key is figuring out whether Kubernetes is reacting correctly to a real problem, or whether configuration is causing unnecessary restarts. Another question. How do readiness and liveness probes differ, and how can they cause failures if misused? A strong answer would be, liveness probes tell Kubernetes whether a container should be restarted, while readiness probes control whether traffic is sent to it. If liveness probes are too aggressive, healthy pods can be killed unnecessarily. If readiness probes are wrong, traffic can be sent to pods that aren't actually ready. In production, misconfigured probes are a common cause of instability. Next scenario. A deployment rolls out successfully, but users start seeing errors immediately after. Kubernetes reports everything as healthy. What do you do? A good explanation would be, I don't trust the green status alone. I look at application metrics, logs, and user-facing behavior. Kubernetes health checks might only verify that the process is running, not that it's functioning correctly. I consider rolling back while investigating further because a successful rollout doesn't always mean a successful release. Another question, how do resource requests and limits affect scheduling and failure behavior? A strong response would be, requests tell the scheduler how to place pods, while limits control how much they can consume at runtime. If requests are too low, pods may be packed too tightly and compete for resources. If limits are too low, pods may be killed under load. Misconfigured requests and limits are one of the most common causes of unexpected failures in Kubernetes. Next scenario. Why do Kubernetes issues often look like application issues at first? A solid answer would be, because Kubernetes is designed to keep things running, it often reacts automatically to problems by restarting or rescheduling pods. That can hide the original cause and make it look like the application is unstable. Understanding Kubernetes failure modes helps you recognize when the platform is responding correctly versus when configuration or application behavior is the real issue. Another question. A node in your Kubernetes cluster becomes unhealthy and several pods are evicted. Traffic degrades, but Kubernetes eventually reschedules the pods. How do you reason about whether this is an acceptable failure or a sign of deeper problems? A strong answer would be, I start by asking whether the system behaved the way we designed it to. Pod eviction and rescheduling are normal Kubernetes behaviors, but I want to understand why the node became unhealthy in the first place. I look at resource pressure, disk issues, or network problems on the node. If this was a one-off hardware or cloud issue and the system recovered quickly with minimal user impact, that might be acceptable. If it happens repeatedly or causes noticeable degradation, then it's a signal that capacity planning, resource requests, or node health monitoring need improvement. Next scenario. A deployment update causes a rolling restart of pods, and during the rollout, error rates spike even though replicas are configured correctly. How do you debug this? A solid response would be, I look closely at rollout behavior and traffic patterns. Even with multiple replicas, brief spikes can happen if new pods take longer to become truly ready than Kubernetes thinks. I check readiness probes, startup time, and whether connections are being dropped during pod termination. I also review the rolling update strategy to see if too many pods are being replaced at once. The goal is to make sure capacity and readiness overlap correctly during deployments. Another question, how do pod disruption budgets influence failure behavior in Kubernetes? A strong answer would be, pod disruption budgets don't prevent failures, but they influence how Kubernetes handles voluntary disruptions. They tell the system how many pods can be unavailable at a time during things like node drains or upgrades. In production, they help protect availability, but they can also slow down maintenance if set too strictly. I treat them as a balance between safety and operational flexibility. Next scenario. Your cluster looks healthy, but a single service keeps failing intermittently. Other services are fine. How do you approach this? A thoughtful response would be, I start by isolating what's unique about that service. I look at its resource configuration, dependencies, and traffic patterns. I also check whether it's more sensitive to latency or resource pressure than others. Kubernetes issues often affect everything, so when only one service is unstable, it usually points to application behavior or configuration rather than the cluster itself. Another question, how do you think about horizontal pod autoscaling when it comes to failure modes? A strong explanation would be, autoscaling helps handle load, but it can also introduce new failure patterns. If scaling reacts too slowly, pods can be overwhelmed. If it reacts too aggressively, it can amplify instability or cause resource contention. I monitor scaling behavior closely and make sure metrics reflect real load, not noise. Autoscaling should smooth traffic, not create oscillations. Next scenario. A Kubernetes service is reporting endpoints, but traffic isn't reaching the pods. What do you investigate? A solid answer would be, I check whether the pods are actually ready and whether the service selector matches the pod labels. I also look at network policies and whether traffic is being blocked. From there, I consider kube proxy behavior or underlying networking issues. Even small mismatches in labels or readiness can make a service appear healthy while still dropping traffic. Another question. How do cluster-level resource shortages show up as application failures? A strong response would be, when a cluster is short on CPU, memory, or disk, applications may fail in indirect ways. Pods might be evicted, throttled, or scheduled onto less suitable nodes. From the application's perspective, this looks like random restarts or latency spikes. That's why I look at cluster-level metrics alongside application metrics when debugging failures. Final question for this section. When Kubernetes automatically recovers from a failure, how do you decide whether to investigate further or move on? A mature answer would be, automatic recovery doesn't mean the problem is solved. I look at impact and frequency. If recovery was fast and isolated, it might be acceptable. If the same pattern appears repeatedly, it's worth investigating even if users aren't complaining yet. Kubernetes hides failures well, but ignoring those signals can lead to bigger incidents later. Let's move into the final part of this interview. These scenarios are intentionally ambiguous. There isn't a perfect answer. What I'm listening for is how you reason about risk, how you prioritize under pressure, and how you decide what to do when Kubernetes is behaving as designed, but users are still impacted. Here's the first scenario. Your Kubernetes cluster is under heavy load. Pods are restarting, autoscaling is active, and the control plane looks healthy. Users are experiencing intermittent errors. Some engineers want to keep tuning Kubernetes settings. Others want to roll back the last application change immediately. What do? A strong answer would sound like this. I start by separating symptoms from causes. Kubernetes scaling and restarts might be reacting correctly to pressure, but that doesn't mean the platform itself is the root cause. I look at what changed most recently and whether that change increased resource usage, latency, or error rates. If rolling back the application change is low risk and likely to reduce load quickly, I'm open to doing that as a mitigation. At the same time, I keep investigating whether cluster capacity or configuration is contributing. My goal is to reduce user impact first, then understand whether this was an application issue, a capacity issue, or a combination of both. Next scenario. A critical service keeps failing readiness checks and is removed from traffic, but when you manually inspect the pods, they appear to be working fine. The team is debating whether to disable the readiness probe temporarily. How do you decide? A thoughtful answer would be, I treat readiness probes as a contract. If the probe is failing, either the probe is wrong or the service isn't actually ready in the way we think it is. Disabling the probe might restore traffic, but it also removes a safety mechanism. I'd look closely at what the probe is checking and whether it reflects real readiness. If the probe is too strict or brittle, I might adjust it. If the service truly isn't ready, I wouldn't bypass the probe just to make the system look healthy. Another pressure scenario. During a production incident, Kubernetes keeps rescheduling pods to different nodes, but the failures follow the pods. Some people believe the cluster is unstable. Others believe the application is broken. How do you reason through this? A strong response would be, if failures follow the pods rather than the nodes, that's a strong signal the problem is tied to the workload, not the infrastructure. Kubernetes moving pods around helps eliminate node-specific issues. I'd focus on application configuration, dependencies, and resource behavior. At the same time, I'd confirm that nodes are healthy enough to rule out systemic cluster issues. Kubernetes is good at surfacing where problems live if you pay attention to the patterns. Next scenario. You're in the middle of a Kubernetes upgrade when a separate failure occurs in production. Rolling back the upgrade might help, but it also introduces risk. What's your approach? A mature answer would be, I pause and reassess priorities. I don't automatically roll back unless there's evidence the upgrade is contributing to the failure. Rolling back a cluster change under pressure can introduce new problems. I look at timelines and symptoms to see whether the issues are correlated. If the upgrade is likely involved and rollback is well understood, I'll consider it carefully. Otherwise, I focus on stabilizing the affected workloads first and resume the upgrade later. Final pressure question. After an incident, someone says, "Kubernetes made this harder to debug," while someone else says, "Without Kubernetes, this would have been worse." How do you handle that conversation? A strong answer would be, I acknowledge both perspectives. Kubernetes does add abstraction, which can make debugging harder if you don't understand it well. At the same time, its ability to restart, reschedule, and isolate failures often reduces blast radius. I steer the conversation toward what we learned about our system and our assumptions. The goal isn't to defend or attack Kubernetes, but to understand how to operate it better and design systems that fail more gracefully. Now take a moment to reflect on this interview. Think about which questions felt straightforward and which ones forced you to slow down and weigh trade-offs. Kubernetes is built to handle failure, but that doesn't mean failures stop being your responsibility. The real skill is knowing when Kubernetes is helping you and when it's hiding deeper problems. Let me know in the comments which question you found the hardest and what you would have done in that situation. If you want more long-form DevOps interview simulations like this, subscribe so you don't miss the next one.